Good morning, everyone. I am N.Padmashri. I am going to explain the topic VC in neural network. What is VC called? It is a Varnick-Servonenkis dimension. This dimension is a measure of the capacity of a hypothesis said to fit different data sets. So, measure of capacity. What we are going to measure? We are going to measure the complexity, expressive power, richness, or flexibility of space functions that can be learned by statistical classification algorithm. This was introduced by Vladimir Vapnik and Alexei Servonenkis in 1970. So it has got the name VC dimension. It is a statistical learning theory. The VC dimension is a measure of complexity of a model. It is mainly used to understand how a model is very well fit with the different data sets. The bounds of VC dimension. VC dimension provides upper and lower bound. Upper bound has a number of training examples, which is called logarithmic, and the lower bound is called linear bound. The VC dimension hypothesis has a set H largest number of points, that is scattered H. So if we consider H as a complete set, then there are some points present inside the set that is considered as S. So there exists a hypothesis set. So each point present in a set S which belongs to the hypothesis H. So this is a concept VC dimension. How a line hypothesis class can shatter the data points. This we are going to draw a line that should classify the data which has a similar patterns or similar uh, type similarity should have some similarities. Here I'm going to draw a line because of we are having three similar dots which is of red color, and there are two red dots, two green dots, here two green dots. So your line has to classify the data which is similar type, which should follow a similar pattern. Two green dots, here two red, we can shatter. Here two red, here three green dots. So a line should shatter a point which has a different, which has same similarities. Okay, so 3 point shatter, which is like this is one of the example. Like if you draw the line, like it should find out the shapes or the symbols. So the previous slide we have the symbol of same color minus minus. That is the line has to shatter the symbols. So we see dimension of a set family. It belongs to a set H set family and C is a set. So C should present inside the set H intersection C and small h intersection C and small h or either small h belongs to capital H. Okay, this is basic dimension of a set family. And how will you classify? There will be a set of data points x1, x2, xn, which is present in a model called F. So we need to classify those models. We need to prove that those points should exist in that model. So we see dimension of a model F, maximum number of points that can be arranged so that F, the shatters. More formally, it is the maximum cardinal D, such that some data point set of cardinality D can be shattered by F. So the VC dimension of a neural network is described by a directed acyclic graph G of V comma E. Acyclic graph, a graph which should not follow a cycle, right? So where V is a set of nodes, each node is simple computation set, E is a set of edges, and each edge is associated with its weight. So input to the network is represented by source, that is the starting node, and end is the sink of end node is called the output of the network is represented by the sink, that is called end last node, and each intermediate node gets as the input of weighted sum of the output of node and its incoming edges. So the weights are associated with the edges. Each intermediate node outputs a certain function of its input, such as the sine function, or it can be the sigmoid function. This function can be calculated by using the activation function. So we see dimension of a set family as we already discussed about what is this set family. and how a neural network is bounded. It has some formula. We have to find it out the activation function of a network. Either, as I already said, either it can be a sine function, sigmoid function, that is order of module E into log of E. So VC dimension should have at least omega of module E squared. Okay. So weights come from a finite family. Example, we can say if the weights are from the real number that can be represented at most 32 bits uh, for both the activation function. The next, we have application of VC dimension. So where the VC dimension is actually applied. It has applied in a wide range of application in machine learning and statistics. For example, it is mainly used to analyze the complexity of neural network, support SVM, support vector machine decision trees, and is mainly used to design a new learning algorithm that are robust to noise. Robust to noise is the algorithm has to train the model with has denoising capability. It has to be inbuilt. Can generate well data. VC dimension can be extended to more complex learning scenarios, multi-class classification and regression. The concept of VC dimension is applied to other areas of computer science such as computational geometry and graph theory. So these are all the various applications of VC dimension. The rest will be continued in the next session. Thank you.